So in this project I have made an home automation system. So it's a complete home automation system in which it controls the lighting of the system in live time, and sends the light intensity to the BOLT-Arduino model. So this module sends the light intensity and checks it on real time and manages to keep it on a reference value at real time, and it sends the average value every 30 seconds to the Bolt Wi-Fi module. So this Bolt Wi-Fi module then sends it to the my computer script which is running, and I use it for many applications. So along with light intensity control, I have added the temperature sensor also, and it is sending, and the Bolt module Wi-Fi module is also responsible for different applications such as battery or pump status maintenance, and it can control the charging of an electric vehicle. It can be used as a charging application in electric vehicle, or you can control the pump also, water pump also. So what is happening is, so the Arduino board is connected with an 8 input output pins through a keyboard. So this 4x4 keyboard is used to add the reference values. So it adds it you can submit a U reference value to the Arduino board. So the Arduino board saves this U reference value, and then what it does is it captures the light intensity using LDR sensor input. It also captures the temperature using LM35. So LM35 sensor. So that there two analog pins are used. So here eight input output pins which are digital here, and then what it does is it shows the LCD display, the U reference value on the LCD display. So 4 plus 1 plus 1, that is 6 digital pins I have used for LCD display. And what the Arduino code is written in such a way that it can control the light intensity by controlling the bulb or an LED array, as I have used uh, uh, like a bunch of LEDs it can control using pulse width modulation, and it can modulate the light intensity of a room. So this whole thing is happening at a refresh rate of 0.1 seconds. Okay, so every zero point 0.1 second it takes a sensor value, and it shows it to the LCD display, and it controls the light intensity of the room. So this thing can be done at any time. It's not limited by its refresh rate. So yeah. So once this is done, what it does is it transfers the information to the Bolt Wi-Fi module. So this is happening through UART communication, and what is basically happening is, so this Arduino board captures the values every 0.1 second, and it takes an average of all the values of the light, the temperature, and the U. The U is the value that is being sent to the controller, that is being sent to control the light intensity. So if U is 255, that means the light will be at its maximum brightness. If U is 0, then it will be switched off. So in that way. So it's a PWM pin, so I can control the intensity in that way. So U value it's sending light and temperature value every 30 seconds. So it's a mean of all the intervals. Like there are around 200 intervals in 200 or yeah, I think 200 intervals of 0.15 seconds. So this is not 0.1, this is 0.15 seconds. So it is sending that thing over here. So yeah, after that, after the it is sent over there, so the main value is also displayed on the LCD panel, and plus it the LCD panel also displays the current, uh, LM35 and LDR sensor reading also. So after that, what is happening is the Bolt Wi-Fi module is then passing it to the this is the computer part. So these are all the scripts that I have written. So what is happening is U, light, temperature, and battery status. So battery status I will explain it later. So these things are transferred to live data from Bolt script. So this script, what it does is it creates a text file in JSON language, and it saves the value of U, light, temperature, and battery status into the text file. Sorry, U, light, temperature, and the timestamp it saves into the text file. So if the reading is taken at let's say today, today is what I think 15 slash September slash 2019, that date plus the time, so let's say 11:45 if it has taken, so 11:45:00 it will send the timestamp as well. So this text file will now contain U, light, and temperature values. And yeah, so secondly, once this text file is created, I can use it for multiple applications as I have done over here. So after that, what I'm doing is I've written a web scraping algorithm. So this algorithm, what it does, it takes the live real time market value of the electricity. So in California, what happens is, so in India it is not happening in this way, but in California it is, what happens is there are real time markets of electricity where the electricity price is changing every 5 minutes. So I can get a real time electricity market value from their official website. So this web scraping algorithm I have written, and this scraping algorithm, what it does, goes to the site, it downloads the page, it copies the cost of the real time market, and then it saves it into a text file in JSON format. So what it contains is cost and the timestamp in the sense it is the date and time of the date and time at which the cost is recorded. So this algorithm is refreshing at every minute, so it doesn't make sense to refresh it at the remaining, like this thing is refreshing at 30 seconds, so it doesn't make sense to refresh it at 30 seconds, as the rate is changing every minute, not every 5 minutes, not every 30 seconds. So unnecessarily it will cost the computer to lose its power, CPU power. So here I have got the cost of the electricity. Here I have got the light and temperature, and U which is the signal that I'm sending to control the light. So this thing I've got. So yeah. So next, what I'm doing is I have used the light and temperature and the cost in this live monitoring system. So I download the cost, light, and temperature to the live monitoring script. As it is a JSON file, so the I can easily convert it into a dictionary. So this live monitoring code captures the cost, light, and temperature, and then it shows the real time plot of light, temperature, and cost changing with respect to time. So this script is basically for monitoring. So if a user just wants to see how the light has fluctuated, how the light in his room has fluctuated for like 2 to 3 days, then he can use the live monitoring graphs to see it. And if he wants to see how the cost is changing, so in order to monitor the cost, let's say like he wants to see if at night if he charges his electric vehicle, then it would cost low. Then he can see in this real-time plotting. So the live monitoring script is doing that thing. Then what is happening is Then there is the controlling part. So what controlling part does is it captures the cost and u of the light and u value. So what it does is, if the cost of the what it calculates the total energy consumption of the whole system. Yeah, so let me just explain how the battery and electric vehicle or pump has been implemented in this in my project. So what happens is, so let me just give you an idea what how an electric vehicle or water pump charging works. So if the if the cost of electricity is low and I charge my electric vehicle at that point, or what, or you can say that if the cost is low, and if I want to fill my overhead water tank, then at that time it would be much more cost efficient to charge my battery or send turn on my water pump to fill the overhead water tank. As if the cost is very high, then it obviously the overall cost will increase. So what we can do is, we can charge the electric vehicle and pump at the cost when it is low, or when it is feasible, when it is less than average, you can say less than average cost. So what I have done, how I have implemented it is that, if the battery or pump status, so let's say if the battery is fully charged, or the water pump is or the water tank is full, in that case what this Bolt Arduino model will receive is a zero output. So in that case the battery status will change to zero. So if the battery status is zero, then the control won't work here. So as the battery is fully charged, or the water tank is full, then this control algorithm won't work, as it doesn't make sense to further charge the battery or further increase the water in the tank. So what will happen, so in case if the battery sensor value is 1, which means that the battery is not fully charged and the water pump is not fully filled, then it will send a 1 command to here, and this controlling algorithm will sense the status of the digital pin through which the sensor is connected to. So what it will do is, the battery status it will see. If it is 0, then it won't run the algorithm. If it is 1, then what it will do is, it will see if the cost is less than the marginal cost. So the cost it is taking from here, and it is comparing with the marginal cost. So marginal cost is set by the user. So let's say if the average cost over a day is let's say 35, so we can keep, so that means that most of the time the like if I so what it means is that over a period of time, over a period of one day, the cost is fluctuating around dollars $35 per megawatt. So if the cost is going below 35, then I can start charging my battery or electric vehicle or pump. So yeah. So it will compare the cost and the marginal cost. If the cost is less than marginal cost, then it will change the battery status to 1, and the electric vehicle and pump will start to actuate. So, it also calculates the total energy consumption. So, if the electric vehicle and pump is active, then it knows that the electric vehicle takes some, let's say, 10,000 watts of energy per 10,000 watts of energy, and the pump takes a, let's say, 4,000 watts of energy. So 4,000 watts of power, sorry, not energy. So it calculates it over the period of time for which the electric vehicle and pump is active. It also adds the U thing. So U is the U, as I said, it was the control. uh, the PWM signal that was sent to control the light of the room. So it will sense the light, it will sense the U, that is a control uh, signal, and it will multiply it by a factor, similar factor, and it will add its energy also. So if the room is, let's say, lit by 100 units, then it will multiply it by the similar factor. So let's say if a bulb takes if a bulb shining at 100 lumens takes let's say 50 watts of power, then it will add the 50 watts of power to this thing, to the energy consumption, and show the total energy consumption. So yeah, so it calculates the total energy consumed by electric vehicle, pump, and the indoor lighting system, and it saves to a text file which is in JSON format. So energy consumed and timestamp, these two values are same. So timestamp of the recorded energy value. So yeah. So what the next thing what it does is, this code does is, if the battery status is 1, if it sees that the cost is less than marginal cost and it has to charge the battery, then it will send a command to Bolt Wi-Fi that, okay, so the cost is very less, so you can charge the pump. So the Bolt Wi-Fi module is connected to the electric vehicle or pump, and then it commands it to turn on the charging. So this is the driver circuit. So using this, I can command the electric vehicle or pump to start charging. Okay, so yeah, so that thing it does. So basically, three functions. It calculates the cost. It calculates the energy by adding all the parameters. It sends the command to activate the electric vehicle or pump, and it saves a JSON text file showing the energy consumed. So what is also happening by this controlling algorithm is that it is generating a real-time energy cost curve. So this is actually a mistake. So anomaly detection script is not generating the real-time cost curve. It is a controlling script that is generating the cost curve. So yeah, it calculates the total energy consumption and shows it with respect to times. So it adds up the cost at every instant, and shows the total cost. So if you see the latest value of this graph, then it will show you that, yeah, okay, so I have consumed up to, let's say, $1 of energy I have consumed today, or like at the present time, up till now I have consumed, let's say, $0.5 or something like that. So the anomaly detection script, what it does is, once it has the energy consumed and timestamp, it calculates the z-score. So every 30 second it takes a reading, and it adds up till, it has 10 values. It forms a list, and then after 10th value it starts calculating the z-score. And if the energy consumption graph is within the z-score limits, then it's okay. If it goes out of the z-score limit, that means the energy usage has suddenly increased. So in that case, it will send a SMS or a mail. So basically, what z-score does is, it finds if there are sudden increases in energy consumption. So let's say if originally the the light was, let's say, 0, and suddenly if someone increases it to a full value, then it will send an SMS or a mail. Or let's say if the battery or pump was inactive for some time, and suddenly the cost reduces, and this controlling command sends the value, the controlling script sends the value to Bolt Wi-Fi module, and then it actuates the electric vehicle charging. Then the energy will suddenly rise. As electric vehicle and pumps are very heavy power equipment, so detect that Z-scope will detect that, and it will send a mail and SMS that the energy has suddenly increased. So just have a look what all the appliances are working. So, and the third thing what it does is, if the cost is greater than cost of let's say a threshold value, so then it will send a mail and an SMS alert. So let's say if the cost is very high, like it increases to let's say 100 dollars per megawatt. Generally it is around 20 to 40 or 45 maximum. It is fluctuating, but in case there are some market issues or some like uh, faults and all, then the price can go high up to 100, 200, 300, up to that thing. So if it is increasing, so your threshold cost I have kept $50 per megawatt. So if the cost is going above $50 per megawatt hour, then it will send a SMS and a mail alert to the user.